Welcome to this module presented by JCB EduBuild Solutions, founded by engineer James Bolo. The structural integrity of any commercial plumbing system is determined at the microscopic level of a single intersection. Mastering joint specifications requires a precise understanding of the mechanical, thermal, and chemical interfaces mandated to lock these intersections together. The stakes at these connections are absolute. Every joint must maintain a gas-tight and watertight seal while withstanding the dynamic, fluctuating pressures of the surrounding network. To guarantee this integrity, Filipino master plumbers are legally bound by the parameters codified in the revised National Plumbing Code of the Philippines. Our objective in this session is to categorize the code-mandated connections by their underlying sealing mechanisms and their absolute dimensional tolerances. Internalizing the physics of these interfaces provides the logic needed to derive code requirements deductively. This diagram illustrates a bell and spigot cast iron pipe. Heavy networks rely on mechanical sealing, utilizing compression to block leaks. The annular space is packed with oakum, then sealed with molten pig lead. This lead layer must precisely reach a 25.4 mm depth. After thorough caulking, the finished joint cannot extend more than 3.2 mm below the hub's rim. Moving to threaded iron joints, standard taper pipe threads are required. Threaded plastic pipe must withstand thread shear forces, thus requiring a Schedule 80 minimum wall thickness. Not all heavy systems use lead or threads. Hubless cast iron and vitrified clay sewer pipes require modern elastomers to maintain their seals. Hubless cast iron soil pipes must use shielded coupling joints that conform to strict IAPMO installation standards. For vitrified clay sewer pipe, the joints are formed using neoprene gaskets between the hub and spigot. Across all these variations, mechanical joints achieve their integrity by exploiting highly specific compression forces and exact material densities. Watch this macro-level view. Precision piping networks rely on thermal interfaces, where the bonding agent is drawn into the microscopic gap via capillary action. For copper swept joints, surfaces must first be mechanically cleaned until bright, then fluxed with a non-corrosive agent to allow the alloy to bond. When these systems convey potable water, the chemical constraints are absolute. The lead content in both the solders and fluxes must not exceed 0.002. Wiped joints, which connect lead pipes or fittings to brass or copper, have their own specific geometry. The exposed surface of the joint must extend at least 19 mm on each side. Additionally, the joint itself must be at least as thick as the material being joined to ensure continuous structural strength. Chemical interfaces govern plastic pipe connections. Solvent cementing uses a chemical reaction to melt plastic surfaces together, strictly adhering to IAPMO installation standards. The code issues specific prohibitions here. Job-fabricated female screws for PVC water piping are illegal. You must use factory-made screws and PVC adapter fittings to maintain precise tolerances. Thermal and chemical bonds secure the network by physically altering the surface of the pipe itself, requiring absolute purity in the bonding agents to function. This compatibility matrix highlights a vulnerable point in any plumbing system, the transition between dissimilar materials, where engineering variables multiply. When connecting thin-walled copper tubing to a thick-walled threaded pipe, you are required to use approved brass adapter fittings to bridge the mechanical gap. To transition wrought iron, steel, brass, or copper pipe into cast iron piping, the connection must be secured using either a caulked joint or a threaded joint with approved adapter fittings. Beyond material differences, connections must compensate for structural stress. High-rise soil and waste stacks require expansion joints to absorb the natural settlement and thermal movement of the building. Slip joints are permitted in fixture drains and traps, but due to their design, the code places severe access restrictions on them. If used in supply piping, they must remain fully exposed for maintenance. The final critical interface is where the fixtures themselves connect to the drainage network, particularly earthenware trap standards like toilets and pedestal urinals. These fixture connections must be bolted to a firm base using rust-proofed materials and sealed with an approved gasket, washer, or setting compound. The flanges bridging this connection are strictly regulated. The code approves flanges made only from brass, hard lead, ABS, PVC, or iron. Dissimilar transitions represent the points of highest potential failure. Strict adherence to prescribed adapters and materials provides the only safeguard against system compromise. This diagram shows the fluid dynamics inside a drainage pipe. The top illustrates turbulent flow, accumulating solid waste, while the bottom demonstrates perfectly smooth laminar flow. This physical reality dictates a central rule. A drainage system cannot tolerate any fitting that abruptly alters its internal cross-sectional profile. Consequently, the code strictly prohibits any fitting or connection featuring an enlargement, a chamber, or a recess with a ledge or shoulder. These prohibited geometries act as abnormal obstructions. They create friction points that destroy laminar flow and guarantee eventual clogs and system failure. However, the code provides one highly specific geometric exception to the rule against enlargements. The enlargement of a 76 mm closet bend or stub to a 102 mm diameter is officially recognized as an acceptable transition, not an obstruction. Every single dimensional tolerance, approved material, and prohibited geometry we've covered traces back to this exact operational imperative. The specifications are designed to achieve one objective: maintaining uninterrupted hydraulic flow and pressure across thousands of interconnected joints. On behalf of Engineer James Bolo and JCB EduBuild Solutions, we hope this technical breakdown serves your preparation for the licensure exam. Mastery of the National Plumbing Code requires an internalization of the invisible physics necessary to protect hydraulic pressure and flow.